So now this video is inspired by a comment I got, and I think it answers the question that I got. So somebody wanted to know something about lighting an LED when the reset pin is activated. And so what we have here, we're going to wire this in bistable mode. And so there are a number of jumpers that they don't really block anything. So I will discuss them first. So we have to power the 555 timer. This is an NE 555. So pin number 8 there, top pin on the left to the positive rail, and then pin number 1 there to the negative rail. So that's any time you wire up a 555 timer, you have to power it. And there's also, let's get this one out of the way. We are telling pin number 6 here, the threshold pin. It monitors the voltage. It looks for a higher voltage, close to the rail voltage by about 2/3 of the power supply. And this brings it right down to 0 volts, tells it to do nothing. Now, that's kind of it for that. We have a switch going to the trigger pin because it's going to be a bistable mode. So that will trigger it or set it. And then we have a switch here with the little jumper, bringing it to pin number 4 down there. So trigger pin is pin number 2. Pin number 4 is the reset pin. And so that's the one we're interested in. So these are active low. You'll see that the switch is separating the pin from the negative rail. And we want to make sure it has a high signal, a voltage that is the rail voltage basically, but we don't need any current. So we can take a resistor. We can either put it to that pin of the switch, or we could put it right to the input or the threshold pin there. So I'm going to put it to the threshold pin so it's a little easier to see. So that's going to keep a positive voltage to that pin, telling the pin not to do anything. So we're going to do the same thing with the reset pin. And the ZAG value resistor doesn't matter, but 10 kilo ohm works nice because it doesn't impact. When you close the switch and it goes to ground, not a whole lot of current is lost, but it is still a low enough weakness to make sure that those pins have a positive signal there. So that's it for the actual wiring of a flip-flop right there. So the threshold pin, pin 2, is getting a positive signal, and then the reset pin, pin 4, is getting a positive signal. The power is off right now, but we're gonna light an LED as a load. So the output is pin 3 right there, and there we go. So third pin down on the left, right between the trigger and the reset pin. And then we're going to come up here to the top lead of the LED. And so LEDs are a type of diode. They only conduct in one direction. So the long lead, the anode, needs to be where the jumper is. Short lead, the cathode, goes down one row to this resistor, which I have leading to the negative rail. 220 ohm resistor. I'm going to turn the power on, and we don't see anything yet. We hit this switch. Now the output is high, and then that switch, the output is low. That LED is off. We'll come to this LED coming up. So the question was, and this will be in the title, so I haven't addressed it yet, but it'll be in the title. We want to, in this case, hopefully I'm answering the question properly, have an LED light up when the reset pin is pressed. So again, we have an LED. Now you're going to notice the protective resistor is to the positive rail. The long lead, the anode, now is to the resistor, because that's going to be more positive. The short lead, the cathode, is up one row, and we're going to take another jumper, and so I got this black jumper. It's less obnoxious, it's not as long, but we're going to go to, we can either go to pin 4 or come to where the switch is, or even over here because it connects across there. So let's go over there. That's a little more out of the way, a little less black and stuff. So this is all connected right there. The switch is only separated top to bottom until you press it. So we come over here, and so the reason why we wired it like this, so let's get the LED back on by pressing the set button right there. So I triggered it, and it's going to hold the output high until we reset it. And so when we reset it, you're going to see this LED light up while I am pressing the button. As soon as I release the button, it turns off. And so this LED has nothing to do with what the output's doing. All it's doing is lighting up when the switch is pressed. And hopefully you can see why. So we have the resistor to the positive side of the power supply, the LED. Now it comes up here. Over here, it connects to that jumper and to, well, both the reset pin and to this resistor to the positive. So we got positive to positive. So the LED is not lighting up. When we close the switch, it bridges this gap here. So we get a direct connection to the negative rail. So that goes both to the input there, the reset pin, and also the resistor, so it goes to 3 spots. It will let a little current go through, but little current this way, but it's going to hold the reset pin to ground, and whatever current's lost there will not affect this. This is connected directly to ground. And then this side of the LED, when we close the switch, connected directly to ground. So since it's positive there, it can conduct. So this is kind of interesting circuit addition, because let's say I'm not pressing a button to reset it. Let's say I press a button to set it, and the switch is starting to come out, and luckily it still worked. But where do I need to connect that? There we go. This board kind of rejects non-wire pins. But in any case, let's say we set it for whatever reason. The output's high now. That switch is not going to cooperate. And we have something else that resets it. But we don't know when it's resetting or anything. We don't know when it's giving a negative signal to the reset pin. We could add this circuitry there because it will light up. And so let's say we try to set it and it doesn't work. The output doesn't go high, and we don't know why. An LED would be lit up to let us know, because the reset pin is the dominant pin in the 555 timer. If it has a low signal, it's going to keep resetting no matter what. It overpowers anything. And so if we have a signal coming in, we could see that signal just keeps going to that reset pin. And maybe that's why the 555 timer is not working as we think it should. We will know because the reset's getting a signal. So, in any case, hopefully that all made sense. Hopefully it answered their question. And because this is an active low input, so this is a little unusual to light an LED from a low signal. But since this is an active low pin and we're interested in when it's getting a low signal, we just divert some of that signal to an LED. And so the short lead, the cathode, will have to go towards the signal side and then end its journey at the positive rail. And we'll need a protective resistor because it's going directly from the negative rail to the LED, and so we have to limit current. So I'm using 5 volts. 220 ohm resistor is plenty fine to limit the current and keep the LEDs bright, as we saw there. So hopefully that all made sense. Thanks for watching. I will see you in the next video.